Now we will introduce the method of substitution. Okay, so this method consists in taking a factor inside the polynomial and substitute it to make it look a little bit more organized. What do I mean with this? In this case, we have this horrible number. Look at this, x to the 8th power. That will be so difficult to factorize. But I have a solution. What about if I say, hey, I want to call x to the 4th power, I want to call it u. Yeah, as an example. I set up a substitution here. Now, wherever I see an x to the 4th power, I'm going to write u. Okay, so how can this be applied to this polynomial? Well, we have 15, then x to the 8, that could be rewritten as x to the 4 square, right? Because remember that when you have the power of the power, is the multiplication, right? So it will be 4 times 2 is 8. Then we have plus 42 x to the 4, and then we have the 24. It doesn't change because it doesn't have any x, so there's nothing that I can substitute there. Okay, now, so we identify, now we have x to the 4 and x to the 4, and we said that every time I see x to the 4, I'm going to write u. So let's rewrite this. We have 15, then u squared, then I have 42 u plus 24. And did you see that this polynomial looks way better than this? We have now a square instead of an a, we have a 1 instead of a 4, and then we have a constant right here. So now with this polynomial like in this shape, we can apply the AC method to factorize this polynomial. Okay, so since we already discussed the AC method, I'm gonna go a little bit faster in this process. Okay, so the first step is to identify ABC. In this case, is A is equal to 15, B is equal to 42, C is equal to 24. Then we have A times C will be 15 times 24, and this is equal to 360. Now we take 360 and start breaking it down. We start with 1 and 360, but then instead of going like 1, 2, 3, 4, 5, I need to see what number I need to get when I add it or subtract it. I need 42. So do you see the big difference between if I add or subtract these two numbers, right? If I add it, I get 361, and if I subtract it, I get 359. So that's way different than 42. So maybe I need to get two numbers that are closer to each other, that I could get either an addition of 42 or a difference of 42. So maybe let's try 8. To what number do I have to multiply 8 to get 360? To 45. Then let's see, if I add 45 to 8, what number do I get? 53. So that's not good. And if I subtracted 45 minus 8, 37. No, that's not good either. So let's keep trying. Then let's try 9. 9, to what number do I have to multiply 9 to get 360? To 40. If I add it, I get 49. And if I subtract it, I get 31. No good. Then let's go to 10. What number? It should be 36. If I add it, I get 46. Not good. And if I subtract it, I get 26. Not good either. Okay, so let's try to 11. No, 11 doesn't work because 360 is not divisible to 11. So let's try 12. 12, to what number do I have to multiply 12 to get 360? To 30. Okay, if I add these two, I get 42. Oh, 42, the number that I want. Okay, so we found our two numbers. We found 30 and 12. Okay, so now once we found our numbers, the next step is to reorganize the polynomial. Remember that we are not working with this polynomial, we're working with this new polynomial. Okay, so let's reorganize it. We have 15u squared plus, instead of 42u, we write 30u. Remember that they have to be added to be 42, and the multiplication should be also positive. Okay, so 30u plus 12u plus 24. Okay, so now we separate it into two terms. We have 15u plus 30u plus 12u plus 24. Now we get the greatest common factor. Here will be 15u that multiplies by u plus 2, and here will be 12 that multiplies by u plus 2. And now we see we have two common factors here, and now we apply the greatest common factor again. We have u plus 2, and then whatever is not common, which is 15u plus 12. Okay, so this one plus this one. And this is the factorization of our simplified polynomial right here. But remember that we have to give an answer to this polynomial right here, right? So what do? We take our substitution right here, the x to the fourth is equal to u. So now wherever we see u, we write x to the 4. Okay, so remember, before we did wherever we see x to the 4, we write u, but now we have to reverse this factorization. So now wherever we see u, we write x to the 4. So let's solve this polynomial, and this will be, the final polynomial will be x to the 4 plus 2 times 15 x to the 4 plus 12. And this is the final answer. So this is now the factorization of the original polynomial. Did you see? So what we did was to substitute, get a factor here to substitute it with an easier variable, so we can have a prettier and more manageable polynomial. And now we can see that we have to use the AC method because the u square is not alone. If it was alone, then we try the difference of perfect square. But since it's not alone, we use the AC method. We get A times C, then get it, decompose it, then rearrange the polynomial, then get the greatest common factor, and return back the substitution. And that's how we solve this problem. Now let's go to the next one. Now we have x minus 3 squared minus 3 that multiplies x minus 3 minus 18. Okay, so here the substitution will be, as you can see, x minus 3, right? So now where we see x minus 3, we're gonna write a w, right? You can use any letter as long as you keep it constant. So here, wherever I see x minus 3, I write w. W squared minus 3w minus 18. In this case, we can see here that the w squared is alone. What does this mean? That we can try the difference of perfect square. Okay, so it says that you need to find two numbers that multiply will give me 18 and added or subtracted will give me 3. Okay, so the steps to follow is to take 18 and decompose it. So 18 will be 18 times 1 is 18, then 2, then this will be 9, then 3, this will be 6. Okay, so let's evaluate. If we have 18 plus 1, this will be 19, that's not good. 18 minus 1, this will be 17, that's not good. 9 plus 2, this will be 11, that's not good. 9 minus 2, this will be 7, that's not good. 6 plus 3, that will be 9, that's not good. And 6 minus 3, that will be 3, that is definitely good because we are looking for 3. Okay, now let's play with the sign. First of all, let's write these two parentheses and we have WW. Remember that the W is 1 power less than the original polynomial. And now we write the two numbers that we found. We found 6 and 3. Remember that we want the multiplication to be negative and the difference to be negative. For the difference to be negative, the greatest number needs to be negative. So we have negative and positive. They need to be different sign because the multiplication is negative. Okay, so now that we have our factorization, we return our substitution. Okay, so wherever we see W, now we write x minus 3. Okay, so we have x minus 3 minus 6, then x minus 3 plus 3. And we put it prettier. We do x minus 3 and minus 6 will be minus 9, and then x minus 3 plus 3, that would just be x. And this is the final factorization for our original polynomial right here. This is how we do the factorization using the method of substitution.